Welcome to the deep dive. We're diving into something you've been wondering about, this whole idea of manifestation, and if there's any science behind it, especially the quantum physics angle.
Yeah, you shared some really fascinating stuff. Seems like there's growing interest in that, this connection between like the science world and this, well, less tangible world of manifestation.
Absolutely. And the material you sent over, it focuses on the work of this guy, Davy. He's a PhD student, actually, chemical engineering at Cambridge, so like seriously science-minded. What's interesting is how he's connecting his scientific background to these more spiritual concepts.
Right, that's what caught my eye too. It's not every day you see someone with a hardcore quantitative background diving into things like, well, thoughts and consciousness.
Exactly. So our mission in this deep dive, it's kind of like a detective mission, right? We're going to unpack these scientific ideas that Davy's putting forward, and we'll see if we can connect them to this whole concept of manifestation that you're curious about. And, we want to make it clear, easy to understand without drowning you in like a ton of scientific jargon.
For sure. No info overload here. The cool thing is science, like traditionally, it's been all about the physical world, the stuff we can measure and see. But now it's starting to explore these connections to, well, things like thoughts, consciousness, like what's really going on in that space. And Davy's work, from what I've seen, it's really pushing the boundaries on that front.
Yeah, it's exciting stuff. And one of the big things Davy talks about, and this is where it starts to get really mind-bending, is he compares our thoughts to frequencies. Like, think about a radio trying to find a station.
Rounding in.
Exactly, tuning in. So Davy says our thoughts, they're kind of like that, constantly trying to resonate with the different possibilities, kind of like tuning into a specific reality within the universe, or, to use the scientific term, the quantum field. It's like, whoa, okay, let's break that down. Where does even the idea of thoughts as frequencies come from? Like, what's the starting point for that?
Well, Davy starts with something we all know, light. Light is a wave, right? It's part of this electromagnetic spectrum. And it exists at all these different frequencies, each with its own energy level, like radio waves, microwaves, X-rays. They're all light, just vibrating at different speeds. But here's the key thing. Light doesn't have mass. It doesn't have a fixed location. It's energy that spreads out like a wave. So that's a pretty fundamental part of our reality, existing without being like a solid fixed thing.
Right. And we know that light, or those electromagnetic waves, they can travel through space, right? It makes you think, if something so fundamental to our reality can exist without being a solid object, what else might be out there that we don't fully grasp yet?
Exactly. And that's where things get super interesting because Davy, he connects this to what's going on in our brains when we think.
Like our thoughts.
Yeah. We know from EEG measurements, those brain scans, that when we think, our brains are actually generating these electromagnetic signals. Like, there's measurable electrical activity happening when we have thoughts.
Oh, wow.
And that's what makes Davy go, interesting. This suggests there might be a fundamental similarity between thoughts and light. They both could be forms of waves existing as frequencies.
Okay, hold on. So we have these measurable electrical signals in the brain, and those signals, they're connected to our thoughts, our thinking process, but as far as science knows right now, we've only been able to measure those signals within or very close to the physical brain itself. Like, we haven't detected them extending beyond that in a way we can easily measure.
Right, and that's where, science traditionally comes in. It loves to study the physical world, things we can measure and quantify, and that's where mass comes into the picture.
Okay, mass, like the weight of something.
More like the amount of matter in something is what gives things, well, a physical presence. And to understand the possible link with manifestation, we need to understand a bit more about how science sees the physical world.
Got it. Let's talk building blocks.
Okay, so think of it like this. Davy takes us on a journey, starting with molecules, the basic units that make up, well, everything, us included.
Right, like the water molecule, H2O, two hydrogens, and an oxygen.
Exactly. And then we go deeper. Molecules, they're made of atoms, like the oxygen we breathe or the carbon that's in, well, pretty much everything. Now, what makes each atom unique? What defines it as oxygen or carbon?
I'm guessing it has to do with the number of protons and stuff.
You got it. And that essentially determines its mass. This is a key point because mass means having a specific location in space and time, which is what makes something, well, observable. We can see it, touch it, measure it. It's like the foundation of our physical reality of what we experience every day.
Okay, makes sense. So we've got molecules made of atoms, and atoms have mass, which gives them a physical presence in the world. But then we go even smaller, right?
Yep, even smaller.
Yeah.
We get to these things called subatomic particles, like protons, neutrons, electrons. These are the super tiny bits that scientists can actually measure. And this is where Einstein's famous equation, E mc², comes in.
Oh, yeah, the one everyone knows but maybe doesn't fully understand.
Right. Well, what's mind-blowing is that Einstein showed us how mass and energy are basically two sides of the same coin. They're interchangeable, connected by the speed of light.
Wait, so energy can become mass, and mass can become energy?
Exactly. It's like, whoa. And think about this. Energy, like light, it travels in waves. It doesn't have a fixed location. It's this stop flow. But mass, well, mass is something solid, something you can pinpoint in space and time. So even when we talk about these physical particles with mass, this idea of waves, and specifically the speed of light, which is like the ultimate speed limit of waves, it keeps popping up.
It suggests there's this deep connection, this underlying link between these things, even at the tiniest level of reality, even if we don't fully grasp it yet. And it makes you wonder, if something as solid as mass can be connected to something as fluid as energy, what else might we be missing?
Absolutely. And it's like scientists starting to realize, hey, maybe things aren't as clear-cut as we thought. And that's where guys like Heisenberg come in. They really shook things up in physics.
Okay, Heisenberg, what did he do?
So he was studying this thing called the photoelectric effect. And what he found blew everyone's minds. It showed that light, which we always thought of as a wave, it could actually also behave like a particle.
A particle, like a tiny speck of something.
Exactly. A tiny speck. They called it a photon. And here's the kicker. It turned out this wave-particle duality thing, it wasn't just for light. It applied to all particles, including the atoms that make up everything around us. But the thing is, the more massive a particle is, the less obvious its wave-like behavior becomes. So it's like even these solid things around us, they have a wave-like aspect to them. It's just hard to see because, well, they have so much mass.
So, like a tiny photon of light, it acts like a wave, no problem. But something bigger, like, I don't know, a chair, we just see it as a solid object in one place. But fundamentally, according to Heisenberg, it has a wave nature too, even though it's really hard to detect.
Exactly. And the main difference between a wave and a particle is this. Waves don't have a fixed location, while particles do. A wave is spread out, a particle is, right there.
Okay, got it. But how do we even know this stuff? Like, how can you measure something that's both a wave and a particle? It sounds tricky.
Right. Well, this is where Heisenberg's uncertainty principle comes in. It basically says that the more accurately you know the position of something, where it is, the less accurately you can know its momentum.
Momentum, like how fast it's moving and in what direction.
Yeah, exactly. And momentum is more of a wave-like property.
Yeah.
So it's like you can't perfectly measure both the particle aspect, its location, and the wave aspect, its momentum, at the same time. There's this fundamental limit.
It's kind of like if you're taking a picture of a race car zooming by. You can either get a sharp picture of the car at one specific moment, but then you don't really know how fast it's going. Or you can blur the picture to show its motion, but then you lose the exact position.
That's a great analogy. And Davey mentions Planck's constant here. So this is like a super tiny number. But it basically determines the scale at which these quantum effects start to become really important. So it's like this inherent fuzziness built into the fabric of reality.
Okay, Planck's constant. Got it. It sets the stage for where things get really weird. And this leads us to, what, the quantum field theory.
Right. So now we're going even deeper into the atom. Davy explains that within an atom, electrons, those tiny negatively charged particles, they can't just be anywhere. They exist at specific energy levels or orbitals around the nucleus.
So it's like a set of stairs. They can be on this step or that step, but not in between.
Precisely. Their energy is quantized. It comes in these specific packets. And for an electron to move from a lower energy level to a higher one to get excited, it needs to absorb a very specific amount of energy, often in the form of a photon of light. And that's what Davy calls quantum jumping.
So it's not like a smooth transition. It's a sudden jump between these defined energy states.
Exactly. Like imagine a frog hopping between lily pads. You can't be halfway on one and halfway on another. It's either here or there. And this idea of the quantum field is basically like saying there's this invisible field that holds all the possible energy levels an electron could occupy.
Okay, so like a field of possibilities for the electron.
Yeah, that's a good way to put it. And here's the kicker. We can only actually observe the electron when it's at one of these specific energy levels, these lily pads. When it's in the middle of a jump, like in between those energy states, its location and even its mass, they kind of become undefined, at least as far as science currently understands it.
Wait, so it's like poof, it disappears for a moment.
Kinda, yeah. Like it exists as a wave of potential and then bam, it materializes again at a new energy level. And this is where Davy makes this mind-blowing connection to manifestation. He's saying maybe the things we desire, they already exist as possibilities within this quantum field, even if we can't see them or measure them yet.
That's a pretty wild thought.
Right, and it leads us to this idea of quantum jumping, not just for electrons, but maybe for our own reality. Think about it. If the electron can jump between these different possibilities, these different energy states, by absorbing energy, could our own reality work in a similar way?
Okay, so let's bring it back to thoughts. Earlier, we talked about how thoughts might be like waves, and waves don't have mass. They're not really limited by space and time in the same way that physical objects are. So if our thoughts are like waves, how do they fit into this whole quantum field of possibilities?
That's a big question, right? Well,
Yeah.
Davy says, imagine for a second that this quantum field theory, this idea that everything has a wave-like aspect at its core, if that applies to everything, then maybe our thoughts are also part of this quantum field, existing as waves within a field of potential thought realities.
So it's like our thoughts are out there existing as possibilities, kind of like blueprints for different realities.
Yeah, that's a good way to visualize it. Like each thought, it could represent a different potential reality, a different energy level within this field. And it's like all those different realities, they're kind of vibrating out there, waiting to be tuned into, like that radio analogy.
Okay, that makes sense. But how does one of these thought realities actually become our reality? Like, what makes it manifest? Is that where emotions come in?
You got it. Davy describes emotions as energy in motion. And here's the idea. Those emotions, they provide the energy, the fuel for our thoughts to make those quantum jumps between different realities. Like emotions, they're the catalyst for shifting from one potential reality to another within this quantum field.
So it's like our emotions are the juice, the power that makes things happen.
Exactly. And if we want to align with a different thought, a desired outcome, a manifestation, we need to provide that emotional energy, like the photon hitting the electron, to jump to that new frequency, that new reality. It's about getting on the same wavelength.
Okay, so if we're vibing high, feeling good, and we're focused on what we want, that's like sending out a strong signal to the quantum field saying, hey, I'm tuning into this reality.
That's the idea. And on the flip side, if we're dwelling on negativity, fear, doubt, that's sending out a different signal, potentially attracting more of that.
So it's all about where we direct our energy, our focus.
Right. And that's a really empowering thought, right?
Yeah.
It suggests we have a choice.
Absolutely. But let's be real for a second. If we're talking about this idea of thoughts as waves in a quantum field, I gotta ask, is there actual scientific proof for this?
That's a fair question, and it's one Davy addresses head on.
Mm-hmm.
Right now, the scientific answer is, well, not in the way we traditionally think of proof.
Like we can't just measure these thought waves directly.
Not yet, at least. And there are some reasons for that. First, think about how science usually proves things. It's about observing, measuring, locating something in both space and time. But if thoughts are truly waves without mass, as Davy suggests, and they're not bound by space and time in the same way physical objects are, then our current scientific tools, which are designed to measure things with mass and location, they might not be the right fit.
Ah, so it's like trying to measure a ghost with a ruler. The tools aren't designed for that.
Exactly. Plus, remember Heisenberg's uncertainty principle. When we try to measure something, especially the quantum level, the act of measuring itself can actually change what we're trying to observe.
Right, the observer effect. Like just by looking at something, you're already influencing it.
Right. So even if we could somehow detect these thought waves outside the brain, the act of measuring them might change their nature, making it difficult to get a true picture. And some physicists even say, because of these fundamental limitations, we might never be able to fully grasp consciousness or thought waves outside the brain using our current methods.
So it's like we need a whole new set of tools, a whole new way of thinking to even approach this stuff.
Possibly, yeah. It's a fascinating frontier. But even without definitive proof, this whole framework, it offers a pretty compelling way to think about, well, the practical application of these ideas.
Yeah, absolutely. So if we take this concept that everything is frequency at its core, and our thoughts are these frequencies existing within this quantum field of possibilities, how can we actually use this understanding in our daily lives?
The key takeaway here is this. Davy says, no thought is actually real, like manifested in our reality, until we give it energy through our emotions.
So it's like the thought is the blueprint, but the emotions are the construction crew.
Yeah, I like that analogy. And the quantum field, it's this infinite source of potential. But we have some say in what we create from that potential. By choosing which thoughts to focus on, which feelings to cultivate, We're essentially choosing which of those possibilities we're most likely to experience.
So it's not about ignoring the negative thoughts altogether, but more about choosing not to give them too much attention, not to fuel them with our energy.
Right. It's about consciously deciding where you want to direct your energy. And the cool thing is, when you start aligning with a desired outcome, when you're feeling good about it, it often leads to what Davy calls inspired action.
So it's like things start falling into place.
Exactly. You're in the flow,
Mm.
you're taking action that feels aligned, and it's easier to move towards that desired outcome because, well, you've already aligned yourself with it energetically.
So, to sum it up, you, our listener, you've been on this deep dive with us, exploring this mind-blowing potential connection between quantum physics and the power of your thoughts. We've talked about thoughts as frequencies, vibrating in this quantum field of possibilities, and the critical role your emotions play in amplifying those frequencies, making them more likely to manifest in your reality.
We've explored some of the key scientific concepts that support this idea, like wave-particle duality, the uncertainty principle, and the quantum field theory. We've also been upfront about the current limitations of science in proving these connections definitively.
And ultimately, it comes down to this. You have a choice. In this quantum field of infinite possibilities, what thought, what feeling, what reality do you choose to focus on and energize? It's a fascinating question to ponder. Thanks for joining us on this deep dive.